Okay, we're going to start this video with a summary of all the rules that we've talked about. So if you want to see all the rules in one place, you came to the right place. All right, and then we're just going to do some of the harder problems. So if you wanted to see some messier problems, this video is for you. If you're not, then turn off the video right now or else. Okay, so we talked about a bunch of formulas. Talked about the inverse property. This one was a double. All right, there's two parts of this one. It says that if I have b raised to the log base b of x, they're inverse functions and they cancel to x. And if I have it the other direction, log base b of b to the x, those cancel as well. We just get x. So, there's just some ways to simplify logarithms. Okay. We also talked about the product rule. The product rule said, if, all right, I've got a colon over here. I don't have a colon over here. I don't like the colons, but I want to be consistent. If we have the logarithm of two things multiplied by each other, that's going to be the sum of their individual logarithms. And we even showed why. It's from properties of exponents. Similarly, right, we had the quotient, which is very similar. That's why I said similarly. If we have the logarithm of some division, that's going to be the subtraction of their individual logs. We talked about the power rule. I said if we had the logarithm of an exponential, let's say x to the p, I think we use that, that power takes a little journey and comes down. It's p times log base b of x. And last but certainly not least, the thing that makes everything work, change of base formula. Change of base formula says that if I have some logarithm, log base a of x, I can change that to any logarithm I want. Log base b of something over log base b of something else. And the a is on the bottom, which means a is going to be on the bottom. The x is on the top, x is on the top. And we can choose any b we want. Any b, technically, it's not equal to, it's greater than 0 and not equal to 1. Those ones, log base 1 is, you don't want to talk about log base 1. You certainly don't want to talk about log base 0 or log base negative numbers. That's a whole can of worms. We're not opening in this class. So these are all the properties we're using. And in this video, we're going to use them all. Okay. So let's get cooking. All right. So. This was going to be example 8, but we already did example 8, which would make it now example 9, because I can count from time to time. Let's separate into as many logarithms. Just separate. Okay. The book has a really, really nice phrasing for this. What does it say? The book says, use the properties of logarithms to expand each logarithm as much as possible. Rewrite each expression as a sum, difference, or product of logs. It basically means separate, okay, for these problems. There's no part A, there's just one part. The common log of 10 times the square root of xy divided by wz cubed. Whoa! How fun. So this is what I mean by complicated problems, all right? We've got a ton of things. All right. So we've got a product to start us off. This is 10 times the square root. So let's productifies this. This is not that. This is the logarithm of the first thing in the product plus the logarithm of the second thing, xy over wz cubed. All right. We can split this up into more logarithms. All right. So we have to use the power rule. And you say, how do we use the power rule? We have a square root that's locking us. Well, remember, square root is an exponent. Furthermore, this is the square root of each individual thing. But we'll save that for later. This is going to be the logarithm of xy divided by wz cubed raised to the 1/2 power. Square root is an exponent of 1/2. And now we could use the power rule. which will give us, let's stop writing log of 10, right? This is the common log. This is log base 10 of 10. The log of 10 is just 1. Look how much writing I'm saving myself. All right, 1 plus this log. Well, power rule says the 1/2 comes down. Now we have the common log of xy divided by wz cubed. And this is where you got to be really careful. Very easy mistake to make right here. 1/2 is getting multiplied by this whole logarithm. So if we split up this logarithm, it's all getting a 1/2. Right? 1/2 is times this whole thing. So if this splits up, everything's going to get this little gift. All right. It's like if you're, cooking a cake, baking a cake or something, you're mixing all the dough. And cake doesn't have dough, it has batter. And, you just spill in some, I don't know, Tapatio or something, or Sriracha or Tabasco. The whole cake's probably going to get it. All right. This is a terrible metaphor. I love Tapatio, so I wanted to talk about it. So we have 1 plus. So the logarithm of the top gets a 1/2. That'll be the log of x times y. The logarithm of the bottom gets a 1/2. And remember, it's quotient rule, so we have to subtract. And the bottom is wz cubed. And now we can keep splitting it up some more. But remember, this is going to have a 1/2 for both of them when we split it up. This one's going to have a minus 1/2 on both of them. Don't forget to spread the love with the Tapatio and the cake. All right, so we got 1 plus 1/2 log of the first plus 1/2 log of the second minus 1/2 log of the first minus 1/2 log of the second. But wait, there's more. We can use the power rule again. So we're going to get very expanded out 1 plus 1/2 log of x plus 1/2 log of y minus 1/2 log of w. Now we use the power rule. This 3 goes wee. 3 times 1/2 is 3/2 log of z. And we have fully expanded out this logarithm. And yes, there are situations where you want to fully expand a logarithm, specifically calculus. All right. If you're taking the derivative, it doesn't look easier, but I promise you it is. It's much easier to take the derivative of this than to take the derivative of that. So any future calculusers, this problem is for you. What a beautiful looking answer. All right. And now we're going to go the other way, okay? In calculus, splitting things up is really nice. In 6.6, which is next week, condensing them is really nice. So sometimes you want to do one, sometimes you want to do the other. So example 10, final example, but it's so fun, we're going to give you 2 parts, right? Condense into a single log. And I'm really excited to talk about when we're going to use this, but you will have to wait a week unless you want to start watching the videos earlier because I'm recording them all tonight. All right, you could see this example and say, I want to move on to the next section right now, and you could do that. All right, example 10 is 2 times the natural log of x plus 3 times the natural log of x minus 1. So we need to combine these, but we can't combine them yet, right? If we add 2 logarithms together, we multiply their insides. Okay? So, but we're not adding 2 logarithms. We have this 2 and this 3 that we have to deal with. So let's use the power rule first to deal with those. Power rule says the 2 goes up to that exponent. We get natural log of x squared. Power rule says the 3 whoops up to that exponent. We get the natural log of x minus 1 cubed. And now we have 2 logs added up together. So we can use the product rule. Say this is the natural log of the first thing, which is x squared, times the second thing, which is x minus 1 cubed. And that is the logarithm as a single one. So there's the expanded form, there's the condensed form. Both have their pros and cons. All right. Part B, last one of the section. 4 times the common log of x minus the common log of y divided by 3 minus the common log of z divided by 3. So a couple things to note here. We got subtraction of the logarithms. Subtraction means these guys are going to end up on the denominator. We also have coefficients though. This 4, right, that goes up top. That becomes the log of x to the 4th. This doesn't look like a coefficient. This looks like division. But remember, right, the log of y over 3, that's the same as 1/3 times the log of y. So these are the same thing. So just watch out for this. So what that means is that 1/3 is going to go up. This becomes minus log of y to the 1/3. Similarly, this becomes minus log of z to the 1/3. And if you want to keep these as 1/3, you can. You could also write them as the cubed root. Okay. So next step is we have the log. Anything with a minus sign goes on the denominator. Anything with a plus sign goes in the numerator. So we're going to get x to the 4th divided by the cubed root. There's the cubed root of y. There's the cubed root of z. And now it's all condensed into this nice, cute little package. And that is 6.5. We're going to use all of these properties to solve equations. We're going to use those equations to solve application problems. That's kind of the way this class is going to end. All right, so it's really, really important to do a lot of these problems and get very comfortable with these properties because they're not intuitive. There's so many mathematical properties that we've been doing so long it makes sense. These ones, you just really gotta remember them, really gotta use them a ton. Remember, we have this table right here. The table has all of the properties, and you need to know these. You need to have these memorized, okay? They should be second nature to you, just like 2 + 2. All right, good luck. Let me know if you have any questions. And, you have an exam this week. Good luck on that as well. And please ask questions if you have them.